So let's go ahead and take a look at how we can convert from one kind of unit into another. For example, to convert between a measurement that we use in what we call the imperial system, like feet and inches, and convert that into something like metric. And to do that, we're going to start with some simple examples that you would intuitively sort of know how to do just some calculations on. But we're going to give you a sense of structure so that when the conversions get really complicated and the numbers get really large or really small, you're still able to do the conversions with 100% accuracy. This is really a crucial skill in a lot of problem solving. So first and foremost, we're only going to do one single calculation across the whole thing. We're not going to do a bunch of calculations as steps along the way where we get decimals and where we round. But let's go ahead and take a look at a couple of quick problems that you might intuitively know how to do. For example, how many minutes are in 4.75 hours? Intuitively, you probably know that you're going to need to do 4.75 times 60, and maybe in the past this is the kind of work that you wrote and you got an answer. Well, we're going to do the same thing, but there's going to be a structure that we're going to use as we use something called a conversion factor. Okay? So the first thing I'm going to do is think about what I'm being given, which is 4.75 hours, and I'm going to go ahead and write that down, and I'm going to make sure that I use a label. The labels here are going to be incredibly important. Finally, the question was about how many minutes, so I kind of want my final answer to have that unit. And what we're going to do is we're going to use what's called a conversion factor right here. So let's go ahead and write this conversion factor out after we have a quick conversation about it. A conversion factor is an example of what's called a unit rate. For example, a unit rate is how many times one thing happens per something else. So, for example, here is an example unit rate. There are 60 minutes per every 1 hour. You might say that you can paint a house in such a way that you paint, 2 houses per 1 week. These are all examples of unit rates that you should have seen in the past. Well, I can also look at this and say, well, I can invert that and say that 1 hour is the same thing as 60 minutes. And these right here are really worth 1 because the 1 hour is the exact same amount of time as 60 minutes, but we're counting the measurements in different systems, different sizes of units. So these are called conversion factors. Okay? They're really just using unit rates that really represent the number 1. And I can use those numbers in such a way that I can convert between units. So let's jump back over to our problem and look at how we would use that. If we take a look at this, we know that we have hours up here in the numerator, and therefore the structure that I'm going to use is going to put hours down in the denominator. Essentially, I'm going to be dividing these quantities. Okay? And I'm going to then put minutes up here in the numerator. So we can go ahead and fill in our conversion factor or our unit rate as 60 minutes belonging to 1 hour, or it's 60 minutes per 1 hour. So this might seem like a little bit of overkill as you begin to get started in this because this problem is very simple. We do hours divided by hours, and we have our final unit in minutes, so we're really ready to go. So really all we do need to do is to multiply 4.75 by 60, which is, really pretty easy to do. We get an answer of 285 minutes. And we might pause just for a second and think about if that answer makes sense, and indeed it does. Let's take a look at another. This question is probably a little bit harder for you to think about how to solve. How many miles is a foot? This is what I'm starting with, 1 foot. And I know that the number of miles should be actually pretty darn small, right? Like it's going to be a small number because a foot is only a tiny part of an entire mile. Now, I don't know why I want to answer this question, but it'll help us to go ahead and illustrate how we can use this structure to our advantage when we need to think about doing away with this kind of math, okay? We're going to stay away from this. So I'm going to follow the same sort of structure, and I'm going to start with 1 foot, and we'll put that kind of like in our numerator. And what I'd like to do is to think about what kind of conversion factor I might use to go from feet into miles. So one quick thing is sometimes I like to draw a little diagram that says, okay, I'm going to go from feet, and what do I know how to go from feet into? Hopefully we know how to go into yards, but we might even know that there is a direct conversion factor straight into miles. So we can do this in one step, from feet into, eventually we're going to have miles here. Okay. So what I always want to do when I do these conversion factors is to look at the feet, and I'm always going to put them in the denominator because I know I want these to divide in such a way as to divide to 1. So I do know how to do a conversion from feet into miles. That rate is 1 mile is equivalent to 5,280 feet. So in order to do this calculation, we really need to divide. I'm going to go ahead and cancel out my units, and what I'm left with is 1 divided by 5,280, and that is the number of miles. And that makes a lot of sense, right? Because 1 foot is 1/5,280th of a mile. It's 1 out of the 5,280 that it takes. So then I could go ahead and do, a decimal conversion here if I wanted to, or this is exactly the answer. However, when I do it on my calculator, it's going to be a little bit more challenging than that because it gives me this weird answer with an e-4, and we need to maybe talk about what that means. What that really means is times 10 to the -4th, which means that we are dividing by 10 to the 4th, or 10,000. So the way I would write my final answer is like this. 0.000, and then I'd go ahead and start. So this is tenths, hundredths, thousandths, and we're talking about the number of 10,000ths, which the calculator said was 1.89. Okay, so the decimal point of course, would not be here. It's just going to be 0.000189, and our units were miles. So this would be the decimal approximation of 1 divided by 5,280. This problem is going to be a little bit more challenging for me to think about, but I should always pause before I jump right into a problem and think about whether my answer should be a very large number or a very small number. In this case, what I'm starting with is 201 pounds, and my question is about grams. So hopefully you have some physical experience with this, but a pound is, quite a bit larger than a gram is. So I give you a conversion factor here, and this is one that you should just kind of know. So what I can do with this conversion factor is write it as 2 different ratios and use whichever ratio is going to suit my purposes. So 2.2 pounds is to 1 kilogram. So these are the same amount of weight. And then the other way that I could write this is 1 kilogram per every 2.2 pounds. So the way I'm going to decide which of these ratios to use or conversion factors to use is going to have everything to do with the way that the problem is set up and what I know. So let's go ahead and do that. First of all, I'm starting in pounds. So I'm going to make myself a little bit of a diagram. I'm going to say pounds, and I know how to convert from pounds into kilograms, but the question is about grams. So we've got to think about kilograms. Can we go from kilograms into grams? And if you know your prefixes, you should. A kilo means 1,000, so we should be able to do that conversion. So without having to do a bunch of random calculations, let's think about how to use the structure. So 201 pounds is what we're given, and then we're going to multiply by a conversion factor that's going to get us into kilograms. If you remember what I said earlier, whatever the unit is up here with pounds is going to go down here so that we divide to 1. And I'm going to go from pounds into kilograms. So the one that I'm going to be using is this conversion factor because it is set up in a way that pounds is in the denominator. So 1 kilogram is 2.2 pounds. So if I stopped right here, did my division, so pounds are going to divide out. If I stopped right here, I'd be in kilograms as my final answer. But I, of course, want to go into grams, so I'm going to add another conversion factor here. And since I'm now in kilograms, we'll go ahead and, of course, put kilograms down here. And we know how to convert from kilograms into grams. So you might notice this kind of structure going on where I'm going to cancel these 2 units, and this is going to be my new unit. So right now, if I stop, I'm going to be in grams, and that's good. So we need to think about this. Which of these is bigger? 1 kilogram is pretty large, and there are 1,000 little grams inside. So the way we're going to do our calculation here is I could punch this all into my calculator all at once. Basically what I would be doing is 201 multiplied by 1,000. And then I would take that entire quantity, so I'd want to put parentheses on my calculator, and divide it by 2.2. I want to do this all at one time. And that answer is going to be the number of grams that we get. So in this particular case, we get really quite a large number. It's 91,363, and then it goes 0.63 forever. We'll go ahead and round it at 0.6 grams. In your science classes, you're going to learn about how precise to give your answers. This is really precise, down to the 10th of a gram, which is really, really small. And when I give you something like 201 pounds, you're eventually going to figure out about how many digits you should actually give in your answer here, and you're going to talk about that anyway in your science classes. But for our purposes right now, this is going to give us a good enough answer as we're getting a hang on how to do conversions. So that's really it for the basics as you convert from one unit into another. Key thing you need to pay attention to is these units and making sure that your units stagger.